Good afternoon, everyone. Am I audible?
Yes.
Okay,
Yes.
thank you. So, hello everyone. Good afternoon. Dear authors and invited guests, welcome to the technical session 6B. I am Raj Nandini Patil, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communication, Pune, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is held today in Pune, India, and the virtual event is being held through Zoom from 19 to 21st of Jan 2026. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it in the chat box. Just before starting the session, I would like to introduce all to the session chair, that is Dr. Lumesh Kautik Ahire. Dr. Lumesh Kautik Ahire is an assistant professor in the Department of Information Technology at Vishwakarma Institute of Technology, Pune, India, specializing in machine learning, quantum computing, and generative AI. With over 17 years of experience and of combined in academia and industry, he actively contributes to teaching, research, and application of emerging technologies in information technology education. Welcome to the session, sir.
Yeah. Thank you, ma'am. Good afternoon, everyone. So let us not waste any time and let us start.
Yeah.
I would like to thank SmartCon team to invite me as a session chair. So I would like to listen all the presentation and then I will make my concluding remark at the end. Thank you.
Okay. Thank you, sir. Now let's start with the first presentation. For this, I would like to call Ogochukwu for the paper title, A Personalized Real-Time Framework for Credit Card Fraud Detection Using Multiple Layer Perceptron Networks. I kindly request the presenter to start with the presentation. I kindly request the presenter to start with the presentation. Okay, let's move on to our next word. For this, I would like to call Muhammad Aziruddin Adhoni for the paper title Adaptive Congestion Mitigation in TCP Network via Reinforcement Aided Feedback Learning Using NS3 regime. I kindly request the presenter to start with the presentation. I repeat. Okay. So for the next presentation, I would like to call Pooja Chaturvedi for the paper title DQN based flow prioritization in SDN. Am I audible?
Yes, you are audible, ma'am.
Okay. And she's not. So for next presentation, I would like to call Prutha Savle for the paper title Legal Ease AI-powered legal assistant using multi-agent architecture.
Yeah, sure, we're ready. Just a
Okay,
second.
I will stop sharing. You can start with the presentation.
Yeah. Just a minute, we're presenting the screen.
Yeah, sure.
A very good afternoon to one and all present here. I am Prutha Savle, and today I'll be presenting our paper titled Legal Ease, AI powered legal assistant using multi agent architecture, accepted at SMARTCOM 2026. This work is authored by Prutha Savle, Professor Satish Bennett, Bhavna Rakshit, Neil Sahasrabudhe, Abdul Shakur Sheikh, and Professor Smita Bhosle. We are very grateful to Vishwakarma Institute of Technology, Pune, and we sincerely thank our guide and teacher, Professor Satish Bennett and Professor Smita Bhosle, for their constant guidance and support throughout the research. Next slide, please. Next slide. Okay, so let me start with the problem that we were trying to solve. Today, the Indian legal system is extremely under pressure. There are over 47 million pending court cases, and for a common citizen, getting legal help is often expensive, slow, and confusing. Many people also face language barriers, low legal awareness, and lack of access to lawyers, especially in rural and semi urban areas. At the same time, traditional legal processes rely heavily on manual document review and legal research, which consumes a lot of time. So, this is where artificial intelligence and natural language processing can play a major role. Our project uses AI not to replace lawyers, but to assist and empower people with faster legal guidance. Next slide. So, based on this problem, we have defined four clear objectives. First is to build an AI system that can understand a user's legal problem, which is written in simple natural language, just like how a person would explain it. Second, we have to automatically identify the relevant IPC sections using semantic understanding instead of basic keyword matching. Third is to retrieve the relevant past cases precedents that support the user's situation. And finally, to automatically generate a structured legal document, such as a complaint or an application, which can directly be used or reviewed. So, our goal is end to end legal assistance from problem description to document generation. Yeah. Next, coming to the motivation behind this work, legal services today are often very unaffordable for a large section of the society. There is also a shortage of legal professionals in the rural and underdeveloped regions. Additionally, legal language is often complex and difficult for ordinary citizens to understand. So, because of manual research and paperwork, the legal process becomes very slow, which can increase the case backlogs. So, these challenges are what motivated us to design a system that is affordable, multilingual, and easy to use while still being technically strong. Next slide. So, this is our system workflow. To give a basic idea of it, it starts with the case intake agent. It starts with user case intake, where the user describes their legal issue in English, Hindi, or Marathi. Next, the system is performing semantic analysis through the agent IPC section agent to identify the most relevant IPC sections. After that, it retrieves similar legal precedents using retrieval augmented generation, which is using the agent legal precedent agent. Next is the legal document drafting agent. So, based on all this information, the system automatically generates a legal document. So, all these steps are handled by specialized AI agents that work together, which helps to reduce the legal analysis time from hours to minutes. Next, I would like Neil Sahasrabudhe to take over this presentation.
So very good afternoon to all. So this is the literature survey which we had prepared for our project. So as given here, we have collected the total of 6 to 7 papers, which consist of the solutions which exist earlier in the world. And now I would like to tell you how different is our solution. So basically, as you can see in the first paper, it just is dependent upon RAG, that is retrieval augmented development, and it also uses Screw AI, which is a in the second paper, which is the framework used for integrating multiple agents. But what new thing by which we have integrated in our paper is that we get the cases from the people. We have an agent which researches about the 10 similar cases and then drafts the letter in its complaint form, which is basically it drafts the complaint in the government authorized form. Then we have also given the functionality to take the input in three languages, that is Marathi, Hindi, and English, which is not given in any of the research papers mentioned over here. Next slide. Next slide. Yeah, so now let's talk about the research gap. So existing tools which are used that rely mostly on the keyword search on the say or in the single LLMs, they have a very poor semantic understanding. So what do you mean by understanding? That they'll not compare the cases to the existing ones, and hence the accuracy will be reduced. Then it mainly focuses on Q&A or judgment prediction. That is, they do not have any complaint drafting agent, as we have mentioned in our system. Then, as mentioned, the third point is there is lack of real-time precedent retrieval from online legal sources. So basically, our agent fetches the data or fetches the cases from indianqanun.org, which is a government website which has the storage of all the cases. So hence, it takes only the verified cases, and hence it is reliable than any other solution. Then all the research papers which we saw, they had the only input feature which takes only English, where we have done new thing that we have added Hindi and Marathi also. Then in I would like to tell our main contribution, that is the multi-agent architecture with the help of Crew AI, in which we have a research agent, a drafting agent. Then we have also used a semantic search with ChromaDB and embeddings, which understands the meaning beyond the keywords. That is, it is able to read the full sentences and the full situation, which is given in the form of prompt. Then we have also automated the legal document drafting, which drafts the complaints, notices, petitions, and all other law-related documents. Then we have also given the multilingual support as mentioned, and it is easily accessible, affordable, and scalable for any people. So if, for example, we have a farmer and a businessman, they both can access this tool because it is very easily accessible to them and it has a very simple UI. Next slide, please. So this was the tools and tech stack which were used. So basically, the framework used was the Crew AI for multi-agent management. Front end was done in the Streamlit, which makes it a very easy user interface. The backend was done in Python. We have used Grok using Llama 3.3 as an LLM. As mentioned earlier, ChromaDB for IPC legal data storage and retrieval. And we have used Tavli, which is used for finding and fetching the cases from indianqanun.org. Then we have used LangChain and sentence transformers for better understanding of the sentences and the complaint. And lastly, the config is we have used python.env for the environment setup of the whole project. Next slide. So now I would like to describe in brief about the advantages and disadvantages. So starting with advantages, our solution or our product is very affordable and accessible. It is time saving because you need not consult a lawyer. Our product gives you the solution and then you can give that solution or the understanding to the lawyer to understand the case further. Then we have a citation backed accuracy. As mentioned, we fetch the data from indianqanun.org, which makes us more reliable than any other solution. And since our UI is in Streamlit, it is very user friendly and it is also scalable because it can handle multiple documents. Then moving on to the disadvantages. The first disadvantage is privacy concern. So the sensitive legal documents may risk data security if not encrypted properly. So it is one of the feature which we have to add. Then large AI models need high computational power. So basically, to run LLMs, we need its credits. So that could be a disadvantage. Then the output depends upon our dataset quality. So in our case, it derives the answer depending upon the number of cases which are listed on the Google or listed on the specific website, that is indianqanun.org. And lastly, there's an adoption challenge. So basically, you know how the traditional system works. So it is very hard for legal professionals and for the common public to rely on the AI to understand their case and to file the complaint. Next slide. So these were the results, as you can see. So on the left image, there is our main dashboard, which consists of the basic UI, and here we have given a prompt box to describe about our case. And once the prompt is given, then there is a final output, and which comes in a certain format, which is devised by our government. Next slide, please. So these are all references which we used for the building of our project. Next slide. And thank you so much for listening to us patiently. It was truly a pleasure to present our paper.
Okay. First of all, should I ask some questions, ma'am?
Yes, sir, you can ask. Proceed with the questions.
Okay. First, I would like to congratulate Prutha and Neil for being here and a nice presentation. So I have just one question here. How you divided your task in between the agent, and what tasks are there?
Okay. So, sir, basically, uh, we have divided into two types. So, as you can see on the screen, there is a case intake agent, which is responsible for note storing the case into the database. Then the second agent is IPC section agent. So this case uses the transformers and the other features to match the problem exactly to the IPC section present in the law. Then, sir, we have the
Okay,
legal precedent.
One more question, Neil.
Yeah.
These tasks are executing in parallel or sequential?
Okay, so sir, these tasks are getting executed sequentially. So basically, when the case is given, then it researches about it, then it starts drafting, then it starts researching, and then it starts drafting. But it is done in a fraction of seconds.
Okay, fine. That's all from my side.
Okay, thank you, Neil and Pritha.
Thank you, ma'am.
Welcome.
So now let's move on towards the next presentation. So for this, I would like to call Prachi for the paper title Machine Learning Based Neonatal Risk Prediction Using Clinical and Demographic Features. I kindly request the presenter to proceed with the presentation. Prachi, are you here?
Hello, am I audible, ma'am?
Yes, you're audible.
Okay,
You can start with the presentation.
just a minute. I will share my screen.
Yeah.
Okay, my screen is visible.
Yes, it's visible.
Okay. Uh, right step. Okay. So, first of all, good afternoon, everyone. My name is Prachi Nekal. So, I'm from the Rajaram Babu Institute of Technology, Rajaram Nagar. And first of all, thank you so much for the SmartCom 2026 for organizing this international conference on the smart computing Okay, so my paper ID is 343, and the title of the paper is Machine Learning Based on Neonatal Health Risk Prediction Using the Clinical and Demographic Features. Uh, so next, first of all, let's see the introduction. So the neonatal period for means first for the 28 days is a very critical part that will the child will faces the different risk during these days. So the neonatal can faces the complications such as the low birth weight or the prematurity or the jaundice or the cyspis, or it can also impact on the some psychological activities. So we have to take care of the child in the first 28 days. So here, the neonatal risk assessment methods are largely manual or the experience driven. So there are no such a techniques are available for handling the complex models or the non-linear clinical interaction. So it can faces different challenges for the newborn babies. So here we are presenting the machine learning based approach that can helps us to analyze a root neonatal clinical and demographical data that will help us to early prediction of the different complications, early resolving the different situations, or providing the automated technology for that. So here are some present theories are available. So these theories can use to the different machine learning models like the random forest, then tree based modeling, then few can use to the classifiers like GBM, Cataboost, or the SMART also. But there are some limitations in all of these, like it can only explore the few regions, or only uh, a small amount of the targeted features. So it can also use the SVM or the decision tree. So these are the different present theories are available currently. So each and every theory has a lot of limitations, like it can use a single data set, or it only focus on the neonatal babies, not preterm or the postterm. So what was the problem definition that I have got is predict whether the newborn baby is healthy or at risk. So I have collected the neonatal clinical and demographic data. So it can collect the it can have the data for the newborn baby from the birth to the 28 days. So overcome the limitations of the traditional neonatal assessment method that can be manual or the subjective, or doesn't work on the complex clinical data or the interactions. So I have developed the robust machine learning based framework that provides a high accuracy, then ROI curve, and integrated into the real world neonatal or clinical decision support system. So let's see the objectives of this project. So I have developed the to develop and evaluate a machine learning model for predicting neonatal risk that can be categorized into the healthy or at risk using the clinical and demographic feature. Secondly, I have done that the key neonatal clinical indicators, means finding the key features from the overall dataset that will directly impact on the output, then analyzing these important features. Then thirdly, I did the reboot and the accurate prediction of the framework that can handles the quality issues, and also balance the imbalance the class. Then fourthly, I go to the AI-based decision support part that will helps us to find the best technology to resolve the neonatal issues or the complications. So this is the how the proposed work actually works. So here are the CSV input features. It can contains the different columns like the IDs, name, then gender, then the weight of the baby, length of the baby, then the circumference of their head. Uh, Likewise, the here we can see the heart rate, temperature, oxygen saturation, feeding type, what kind of feeding process we are done, then the stool count, then jaundice level. So these are the different features or the columns that are available in the dataset. Then I have applied the XGBoost classifier on it. Further, it can classify the data into the risky or the healthy, and it will help us for the clinical decision supports. So what actually the dataset contains? So dataset contains a total 24 features. Again, these are the different features like the identifiers, birth details like the gestational age of the baby, birth weight, then mode of the delivery, then the physical measures like the heart rate, oxygen saturation, temperature, or the jaundice level. Then it can also, again contains the feeding pattern likewise. So what are the target variables? So here we can mention the target variable as a healthy or at a risk. Then further, how it works. So it will take the input as a neonatal, clinical, or the demographic data. After that, it will pre-process the data. Then it did the while doing the pre-processing, it will clean the data, remove the duplicates or the missing values from the data. Then it will provide the feature selection of the data, the features that was selected from the data that will directly impact on the output. Further, it will handle the imbalanced class. Then it will train and test the XGBoost model on the dataset. Then it will provide the risk prediction, like providing the final output like healthy or at risk. And again, it will helps us to for the decision support. Then further, we will see that for the we have split the data as a dataset as a 80% for the training and the 20% for the testing. So XGBoost model will work based on this. So we have removed the non-predictive identifiers from the dataset. So here is the mathematical model, how it actually works. So input features will be shown as a xi for each newborn baby, and we will label the data as a 0 to 1, where 1 is at risk or the 0 is at healthy. So XGBoost can be work as a decision tree over here. So it will take the values as a f of x, and it will do the summation, means do the sum of the decision trees, and it will find the probability. Then it will apply the decision rule. If it is greater than equal to 0.5, it will provide it at a risk, or else it will categorize as a healthy. So here are some experimental design that shows us the data set, number of features that we have taken, then target variables, then balance strategies, then encoding, train and test split, classifiers, and evaluation matrix. So here we can see the balancing strategy for the random downsampling of the healthy class to match at risk level. For encoding, we have used a label encoding for the categorical features and the target labels. For training and testing, we split the data as a 80% for the training and 20% for the testing. Then again, we used the classifier. We again did the binary, means logistic, objective, log loss, evaluation matrix. And evaluation matrix will be provided as a accuracy, precision, recall, F1 score, and ROC AU curve. So here is the performance result for the neonatal. So we can see here as a for the healthy, the precision value is 1. For the recall, it will be 0.9999. For F1 score, it is 0.99. So these are the different results I got from doing the overall process. So final accuracy is at 99.38%. So what are the different important features that I have selected from my dataset? So I have taken the first of all jaundice level from the dataset. Then I have taken the heart rate, oxygen saturation, temperature, and the birth weight. So the jaundice level can directly impact on the output features like the healthy or at a risk. Then heart rate can helps us to find sometimes due to the heavy weight of the baby or heavy weight of the maternal lady, so baby is not able to excrete or it will impact on their heart. So oxygen saturation is an important. So I have taken these 5 important features from the data set, and I have measured the score over here. After that, I have drawn the ROC curve for predicting what are the value will be best for finding the output. So at the end, I will conclude the overall presentation as a I have proposed a XGBoost model for the neonatal risk prediction. So I have achieved 99.38% of accuracy with the ROC curve as a 1. You can see here. Additionally, I have predicted the important features like the jaundice, heart rate, SpO2, temperature, and birth weight of the baby that will help us to support early objective neonatal risk satisfaction and sustainable for the clinical decision support integration. So, what are the future scope I am designing for this work? So, I'm going to validate the model on the multi-center neonatal dataset for the better performance. Also, additionally, I will more add the more nenotals and prenatal features for the like I will add the vital sign data into it, so that will help us to improve the accuracy and the performance of the model. Additionally, I use explainable AI like Sharp or the Lime. Then likewise, I will also work on the maternal lady dataset. So it will help us to find that if the maternal lady is suffering from any complications, what will impact on the baby. So these are the different future scopes, and these are the references that I have referred in my works. So thank you so much for the time, and thank you so much, everyone.
Okay, thank you, Prachi. A nice presentation from you. Wanted to ask, you have extracted 24 features, right?
Yes, sir.
Are they all necessary?
No, sir. Means like the dataset can contains the baby ID, baby name. So these are not directly impact on the output. So we have to resolve them, and we have to fetch only the important feature from the dataset that will directly impact on the output.
Okay. And what is your data size?
So it has total 10,000 of the rows.
And from where you get it?
I actually downloaded it from the Kaggle. So it was recently modified. So I downloaded it from the Kaggle.
Have you verified that data from anywhere?
Yes, yes,
Okay.
yes.
Okay, fine. Thank you.
Yeah, thank you. Thank you so much. Thank you so much, everyone.
Okay, thank you, Chachi. Can you please unshare your screen? And it's humble request to complete your presentation within the span of 10 minutes.
Excuse me, ma'am.
Yes?
I joined a little late. Did I skip my round? My paper is intelligence and or optimization.
Okay. I will inform you.
Yes, ma'am.
I will inform you.
Okay, ma'am. Can I present now?
Is it your?
Yes, ma'am.
Am I audible?
Yes, ma'am.
I will call you when it will be your paper presentation.
Okay, ma'am.
Okay, thank you. So now I'd like to call Preetham for the paper title Multimodal AI-Driven Medical Consultation System Integrating Remote Photoplethysmography, Vision Language Models, and Large Language Models for Enhanced Preliminary Diagnosis. I request the presenter to start with the presentation. Preetham, are you present? Okay, let's move on to our next presenter. For this, I would like to call Anand Kishore for the paper title Net Defend IoT, a smarter way to detect and heal from threats using ML, XAI, blockchain, and self-healing intelligence. I request
Hello.
the presenter to start with the presentation.
Hello.
Hey, are
Am I
you
audible?
audible? Yes, you're audible. You can start with the
Sure, ma'am.
presentation.
Yeah, thank you, ma'am.
Welcome.
Is it visible?
Yes, it's visible.
Okay, sure, ma'am.
Actually, our presentation is not visible. It's on just the black screen.
Is it now visible?
No.
Is it?
No.
Now is it visible?
No, Anand.
Once again, ma'am. Is it now visible, ma'am?
No, Anand. It's not visible. Sir, can you see the screen?
No,
Sir?
it's black screen only. I'm seeing.
Yes. It's not visible.
Okay, 1 minute, sir. 1 minute. Is it visible, sir?
Yes, now it's visible, but yeah, it's loading now.
Okay. Is it visible, sir?
Some, it is not completely visible.
Yes, there is some issue from my side also.
Okay, you can start it.
Okay, so first of all, very thank you for the board members to giving me this opportunity to present my research paper here. So I'm Anand Kishore from College of G.H. Raisoni College of Engineering and Management, and I have completed my final year project with my teammates Mandar Dahibajan and Priyal Mandloi, which is guided by our professors Mr. Santosh Birada sir and Mr. Chiranjit Das sir. And our project title is Threat Defend IoT, a smarter way to detect and heal from threats using ML, XAI, blockchain, and self-healing intelligence. About our project, the Internet of Things, which is IoT, is now widely used in everyday life, but it also brings serious security concerns since IoT devices stay connected to the internet and have limited processing powers, and they are easy targets for cyber attacks also, because kind of attacks like DDoS or brute forces, they consume more power to work on it, and also the IoT devices are not able to consume such power at the same time, which is very vulnerable for the security systems. And the existing intrusion detection systems are not very effective in IoT environment, because they can adapt quickly to new attack patterns and often fail to explain how threats are identified. To address these issues, we propose net-defined IoT, an adaptive and smart security framework which also uses machine learning and detect the real-time intrusions, and also use explainable AI to explain those intrusions and which kind of intrusions are there, at what kind of port it is being introduced, and also how much time it's taking to resolve that issue, and to clearly justify each detection, helping users understand the system's decision. And we also use blockchain to securely store intrusion records and their logs, at what kind of intrusion it is, and at what time it has been detected, and what time we have resolved that issue. Next. This is the introduction which I have already explained earlier in our abstract. Related works. So most existing IoT security system studied primarily rely on federated learning approaches, which is only uses the past described intrusions and only detect those intrusions which has been detected or trained over that same model, which introduce high communication overhead and increased complexity for IoT environments. And we used random forest in our project to offer fast training, low computational cost, and strong performance on imbalanced network traffic, making it suitable for real-time IoT security. Several studies introduce explainable AI techniques like Sharp and Lime to improve interpretability, but they lack automated recovery and self-healing mechanism. But here we have used Sharp for the stable and most accurate explanation of our every step and the intrusion and every kind of port explanation, sir. And for the blockchain in our IoT security framework ensures the tamper-proof logging, but most solutions do not support real-time detection and responses. So because of that, we use blockchain for the real-time logging and securing those logs of our intrusions and their data packets. And our work integrate ML-based detections, XI-driven explainability, blockchain secured loggings, and self-healing intelligence into a single adaptive IoT security framework. This is our methodology. First, we check for the problem definitions, and after we go for the dataset selection and pre-processing. And we have used a dataset of CI/CD 2017, which is widely known for the biggest intrusion dataset, which generates a controlled lab environment and captured using real users and attack scenarios, and each represents a network flow. This dataset have more than 3 million plus network flow records and also have 80 plus flow based features. And we have uploaded that dataset into CSV file format. And according to those features, there are some features like flow duration, total forward and backward packet length statistics, which is minimum time spanning of that intrusion, what will be the maximum time spanning of that intrusion, and then the flow byte per seconds and the packet per seconds, then interval time and TCP flag counts. These are the features which has been used in our project for the model training of our dataset. And for training of our dataset, we divided this big dataset into 8 different small packets, so which makes our dataset easy to train our model. The next, after training and cleaning our dataset, we load that data into our machine learning based detection uh, program, in which we used random forest. And after ingesting our dataset into our ML model, we use explainable AI to explain those every ports and every process of our project stages. And after explanation of that project, we also used blockchain to secure those data and their logs. And after securing those logs, it is also in parallel motions also self-healing those intrusions at the same time, which I have already shared our implementation video with the SMARTCOM board. Next, we have divided our flow into the 2 phases. First one will be the offline mode, in which that I have already said that we collect the data, that is CI/CD 2027. And after cleaning that data, we extracted 86 features, and after cleaning that feature, we process those features, and after reducing the other 3 million, we have come to the final 86 features which has been used in our project. And after training that, we store it into our database, and then we go for the next phase, which is the online phase, where we use Raspberry Pi as our IoT device, which is going to collect the data packets. At the same time, we have connected both our backend and our front end over the same network. After that, it is going to connected with the it is going to connect with our backend, and we have ingested our front end data into the Raspberry Pi. After starting the Raspberry Pi, it is automatically going to fetch the data sets, and also over the same network, if we are trying to share some data with to the different devices, it is going to be work as a firewall, but at the advanced level of firewall, which is going to self heal that intrusion also, which the current firewall isn't doing that. So after fetching that intrusion, our Raspberry Pi will apply same pre-processing, and the ML model is going to detect the intrusions with the help of our model trained data. And if we found any
Try to
intrusion,
conclude. You are already running out of time. Okay.
okay, sorry, sir. Yes, sir. I'll conclude my project. After detecting data, after detecting intrusion, it is going to explain it using the explainable AI, which we have used Sharp to explain our intrusion with very stable with its stability and faster responses. And for securing that explanation, we have used blockchain. And after that, we have self heal that intrusion. And after self healing, it is going to show a dashboard which is going to give the live data of that process. And these are the results which I have already explained in our flowchart. And these are the some backend and front end code. And this is the main dashboard, which I have told you that this is going to be shown after we have completed the intrusion detection. And here you can see the packet analyze, which is going to show how many types of intrusions are there, and the self heal, how many times of intrusions we have self healed at the same time. And the recent activities are going to show by the help of our XZI at which kind of time, what kind of intrusion are there, and what kind of intrusions we have successfully self healed. And at the right side, you can see our model activation, the feature loaded is there, and our monitoring feature is also running or not. And most important thing is our backend and front end is connected with the same network or not. If isn't connected with the same network, it is not going to work. And at the conclusion, developed and net-defined IoT, a hybrid cybersecurity framework that integrates machine learning, explainable AI, and blockchain and self-healing intelligence to secure networks. The proposed framework achieves higher intrusion detection accuracy, lower false positive rates, and faster recovery time compared to traditional IoT security approaches. Explainable AI improve transparency and trust by explaining why intrusion is detected, overcoming the black box limitation of conventional ML models. Blockchain-based logging ensures tamper-proof, verified security records, supported forensic analysis, and improving system reliability. Their self-healing mechanism automatically isolates compromised devices and restores the operations, significantly reduce downtime and human interventions. The net-defined IoT is suitable for real-world applications such as smart cities, healthcare, industrial IoT, and critical infrastructure, and supports the development of service sectors and transparent and resilient IoT ecosystems. That's all from my side. Thank you very much, sir, for giving me your valuable time.
The data pre-processing is very important
Yes, sir.
in your project. Okay. So how you handle the missing values in the data?
So we for that we have already ingested some kind of simulated injection intrusions. So for giving the proper demonstration of our project, that is it working or not. For that we have chosen those features which is related to our
No, no,
ingested
no. I'm
intrusions.
not asking about the feature. I'm asking about the data.
Yes,
There
sir.
are some missing values in data because huge data is required for your
I
project.
yes,
So
sir.
your project receiving huge number of data. So
Yes,
how
sir.
you are going to pre-process that, and in pre-processing, how you are going to handle the missing values?
So for the missing values, there are only null and empty values, which we have already deleted those null and empty values. And for the recovery of
How
that,
you can directly delete the null values? Is it
sir,
possible?
no, sir, not the null values. We have deleted the empty values, and the null values we have replaced those null values with the number one value, which is going to which is going to overcome the overfitting of our data set, sir. We did not deleted the null values. We deleted the empty values.
So did you normalize your data set or something else tool you are using for pre-processing?
So for pre-processing, we have used the our ML model. So we because it is
ML
not
model is not used for pre-processing.
no, so
And
we can use Python models for the pre-processing of
no,
our
so,
data set
so,
because
so
it is very
you are
big
saying
data set.
ML model, na?
Yes, sir.
The ML model is not particularly. ML model is used for predicting classification.
Yes, sir.
Okay.
Yes, sir. I can truly understand what you are trying to say, but we have used not the model, but we have used a code which is going to clean and pre-process that data because this data is very big. So for that we have also divided that big data into 8 different parts, and we have pre-processed those eight data packets one by one so that we do not fall into the overfitting of our data sets, sir. So first, for the pre-processing, we have divided our data into 8 different data packets, sir.
Okay, fine.
Yes, sir.
Next.
Thank you, sir.
Okay, thank you, Anand.
Thank you very much, ma'am.
Now let's start with the next presentation. For this, I will like to call Megha for the paper title, Optimizing Radio Resource Allocation for NB-IoT in 5G Networks Using Learning Framework. I kindly request to start the presentation. Megha, are you there?
Hi, I'm having some network issues. Can I present after one presenter?
It's okay. You can present later.
Okay, thank you.
For the next presentation, I would like to call Khushi for the paper title, Why Young Investors Hesitate Exploring Barriers to AI-Based Personal Financial Advice.
Yes, ma'am.
Yeah, you can start.
Khushi, you will get 8 minutes for presentation. Okay, so just stick to the time.
Can you see my screen, sir?
Yes, it's visible.
Yeah. Good afternoon, everyone. So, my name is Kushi. I am from Amrita School of Business. And the other authors are Ranjanala Ishwari, Tota S. Pavan Kumar, and Suparnare. So, the title of the paper is Why Young Investors Hesitate Exploring Barriers to AI Based Personal Financial Advice. So, for this, I would like to say why I have conducted this research or thought about the research is like this is focusing on understanding why the young investors in India hesitate to adapt the AI based technology for their financial advisory tools despite being very much confident in the more digital era. Key idea here is the adoption hesitation is not caused because of the single factor. There are multiple factor causing this effect. So we'll get on to the introduction part. So we can see the AI is rapidly transforming the financial services. To the many services such as the robo advisors, the people are heavily depending upon taking advices from the AI in order to rely on their financial, but they are not getting the confidence or the trust that is needed for in order for the investments. So we can see that here we have used the ISM and MICMAC, which ISM is giving the interrelationship between the different barriers, and MICMAC is helping to see the driving power and the dependence power of the each barrier. So we'll get on to the barriers. So first barrier is here is the low trust in AI. The young investors nowadays are very skeptical about is the data that we are getting are reliable, or can we get accurate data. And nowadays the youth are more under if they want to understand something, they require a human like understanding manner, which AI lack. So they lack the trust in AI based advices, the perceived investment risks. As the financial market is very unpredictable, so the patterns keeps changing, so it is very difficult to maintain with the trend and to keep changing the decisions according to that. The fear of financial losses, as the financial investment requires a huge amount of money, so a little investment also can cause a huge loss to the investors, which makes them very skeptical about their investments. Over dependence on technology, the youth nowadays are thinking if they are over reliant on the technologies, that is limiting or constraining their decision making skills or controlling their ability to make decisions. Next is the low financial literacy. Here, though the AI is providing us with the proper decisions or the advices, the youth are not self enough that they can interpret it properly. Limited algorithm transparency. So when the AI is giving us certain advices, it is like a boxes, which means they are giving the advices, but they are not giving the proper explanation why those advices need to be carried forward in order to take the investment. Data privacy concerns, as the financial investment or sharing the financial data is a very confidential information. There is a fear of the misuse or leakage of the sensitive financial data. Poor past experience, even if the in the past anyone has faced any problem in the fintech platforms, like any glitches or errors, it ruins or it reduces the future trust in the entire AI based advisory tools. Lack of regulatory clarities. In the AI driven financially tools, we are not sure about who is going to be responsible or accountable for the decisions they are giving us. So this is entirely on us, that we are having to take all the risks that we are making, or we are taking any decisions. Lack of personalized guidance. When we go to a normal like person to person advisors, they provide us with the more personalized guidance, which AI is perceived to provide the standardized guidance for everyone, having the absence of personal touch. The research gap. So, while referring to the previous research papers, we've seen that though they have listed the barriers, but they did not explain how the barriers are interacting well with each other. So, it is the lack of the root cause, the intermediary cause, and the actual cause was missing. So, lack of level of understanding, the hesitation towards the AI advisory tools among youth was missing. The solution target is the foundation barriers, not just the surface level of just that the trust is the main hurdle, but the root causes are like why the people having less literacy knowledge about the financial or the regulatory concerns. The methodology. So first, we've carried forward with the identification of what is the research problem, what are the key barriers that are affecting in making the decisions, reviewing the literature by making the identified barriers suitable for the theoretical frameworks, Design a proper and structured questionnaires. So our sample size was 106, where we have seen most of the people were student going on the undergraduates, and their investments was about the 70% people were having less investment than 5,000. So application of interpretive structuring model. So the proper hierarchical level was needed in order to understand what is the root cause and what is the major causes and which can solve the problem. Use of Micmac analysis to understand the dependent power and the real power. So results and discussions. Seeing on this, we can say the lack of regulatory clarity. That means the clarity and the algorithm transparency. The AI needs to be more transparent with the people and be more able to understand, make them understand that why this decision would be helpful for them to make an investment. System reliability layer. The AI output user, they should give the confidence to the people that they are more reliable. 72% of the respondents reportedly said that it is a discomfort when AI tools did not explain recommendations properly. So cognitive evaluation layers. So 61% of the participants admitted the difficulty understanding the AI insights, like chatbots and black boxes like that. Personalized layers. It felt like AI was very generic and not personalized based, which lacked the personal trust and the personal touch which was needed in order to understand the goals and the financial stage of a investor. Risk perceived as it requires a huge risk in order, like fear of losing money is the main cause that people are facing, so they are not able to trust it properly. Experiential layer. Negative past, like if anything happens in the past, it directly impacts to the trust they have in the AI based advisory tools. So the low trust in AI depends, is is the cause, but it is not the root cause. There are multiple barriers that are affecting them. So comparative. So we are comparing this with the traditional models to use to predict, as the core objective here is the interrelationship between the barriers, not that the single barrier is the only method that is in becoming a hurdle to trust. Methodological, we are using ISM and Micmac, that is causing more proper understanding of this problem. Role of regulations, treating the foundation as the root cause in the study, and the external traditional models. View of the trust, seeing that there are multi barriers that are affecting each other and not a single mediator. Analytic perspective, the system level understanding rather than the leader. That means the solving the trust issue will not entirely solve the problem unless the people are not well educated about the financial literacy and the regulatory compliances are modified. Strategic focuses, they need to focus more on improving the advisory tools of AI. So conclusion is here that the low trust in AI is not the starting problem. There are multiple barriers which needs to be concentrated on. It is a final result of the poor regulation algorithm opacity, low literacy, and fear of losses. AI adoption requires system level solutions, not features fixes. Future works are that we want to spread this to more higher level, more experienced workers, so that the future fintech advisory tools can be improved in order to gain more trust to the investors. Thank you for your valuable time. This is it for our presentation.
Have you studied that already some AI models are already there for financial assistant?
Yes, sir. Certain AI models that we commonly go through are the Zeroda coin or the ET money or the Wealthfront. We've seen these models mainly used by the our respondents.
So mainly AI models are working on previous data. Okay.
Yes.
So do you have any idea about how AI models can handle the uncertainty?
Yes, so they can make people more informed about what is the market research and how is the market working in the present environment, which people are not, because most of the people nowadays who are investing are the students we see. So they are not well aware about the market conditions. So it can help us to know more about what is happening in the financial market by comparing with other companies.
Okay, fine. Thank you.
Welcome, sir.
Okay, thank you, Khushi. Can you please unshare your screen? For the next presentation, I would like to call Pooja Chaturvedi for the paper titled DQN-based flow prioritization in SDN. I kindly request the presenter to start with the presentation.
Yes, ma'am.
Mayor.
So is my screen visible, ma'am?
Yes, it's visible.
Yes. So I'm Dr. Pooja Chaturvedi from Nirma University. I, along with Dr. Aparna Kumari and Deepika Vishnu, have written this research paper titled on DQN-based flow prioritization in SDN. So this is basically we are using deep queue network for prioritizing the flow in the software-defined networking. So first I will go with the motivation and the problem statement. So SDN requires some intelligent quality of service management schemes like route optimization and flow prioritization. And static prioritization method that were traditionally used are highly inefficient because they are static in nature and they cannot adapt to the dynamics of the network topology. So we are exploring that there is a need that we have to adopt and learning based flow prioritization method should be adopted. So in the literature, we have studied several queuing methods like traditional based on first in first out, or there are round robin methods. So these methods were inefficient in case of real time network and where the topology is dynamically changing, and they were inefficient in handling the more complex attacks in the network. So, and ML-based traffic classification methods were also static in nature, and they were based on much simpler data sets, and it required the data set to be labeled. So we are working towards deep reinforcement learning algorithm for the routing and the congestion control. It has been used. So in our work, we are using this for the prioritizing the different flows. Okay, this work is based on the dataset that we have used is in SDN dataset. It is the specific dataset used for intrusion detection. And in that there were 3 CSV file. One CSV file contains of the normals, and second CSV file was based on some meta exploitable attacks that were implemented on the SDN controllers. And third category was OVS, that is basically we are open flow switches which consist of different types of attacks. And the data set we had 84 flow features which determine the different specific properties of the data set, like what is the source IP address, destination IP address, bytes transmitted. Okay, and this is the description. There are total 1,38,722 rows. So in the system architecture, we have first performed the several kind of pre-processing steps in the data set. Like first we have normalized the data set so that all the values lies in the range of 0 to 1. Then we have defined feature selection we have done using the random forest algorithm. Using that, we have identified the top relevant feature across the 84 features. Out of those features, we have selected 48 features. On that, we have implemented our RL algorithm. And RL environment is basically consists of the set of actions that can be performed based on the reward function. So reward function we have defined as a composite function of throughput and delay, and weightage to throughput we have given as 0.6. So we have conducted several experiments and we have found the best weight for the throughput as 0.6 and for the delay factor as 0.4. So using that we have defined the reward function, like if the and based on that reward value we are basically we are comparing with the ideal reward and the reward that we have calculated using our algorithm. And based on that, we have prioritized the flow into three categories: low, medium, and high. So reward function design we have implemented, we are shown in this figure. Okay, and reward calculation is done using the round figure of uh, this is the goodness metric we have defined using the throughput and the delay factor. And using this goodness metric, we have calculated the reward function using this formula. And these are the priorities we have defined to different factors as 0, 1, and 2. So in the first set of experiments, we have used deep Q network, and in the second set of experiments, we have used the enhanced DQN, which is based on the different experience replay function and epsilon greedy approach we have used, and soft target updates methods we have used. So these are the experimental setup in which we have defined the 500 episodes. So basically we have trained our model for 500 episodes. Learning rate we have kept as 0.0001, and discount factor in calculating the reward is 0.99, and three priority actions we have defined that 0, 1, and 2. So based on our implementation, we have found that DQ network was able to converge in the approximately 200 rounds, and whereas enhanced DPU networks converges in the lesser iteration, that is less than 200 iteration, it was able to converge, and it was more efficient for the ideal priorities, and the convergence speed was high. So in the conclusion, we can say that deep reinforcement learning is effective for the flow prioritization as compared to the traditional methods, as it is based on, it also considers the complex attack patterns in the network, and it is well suited for the dynamic network topologies, and it also enhances the quality of service in the HDL. And enhanced DQN also outperforms the basic model that we have defined. And future scope can be that we can test this model on the real-time data set, and we can include more priority levels, and we can also prioritize the experience replay function that we have used in the enhanced DQN. So this is all from my side. If anyone have any queries, you can ask.
Okay, thank you, Pooja. Sir, you can start with your questions.
No question. You can go on
Okay,
next.
thank you.
Okay.
Ma'am,
Yes, if
yes, I can present the paper, right? Adaptive mitigation.
you can present up the next one. Actually,
Oh,
is it okay with you?
Okay,
yes,
ma'am.
ma'am.
Thank you.
Ma'am, can I present? No.
Is this your paper, Narayan?
Intelligence handover, ma'am.
Yeah, you can start with the presentation.
Okay. Is my screen visible, ma'am?
Yes, it's visible.
Good afternoon, everyone. My name is Narayan Kul. I am from Department of Electronics and Communication Engineering from Kelly Technological University. Today, I will be presenting our work on handover optimization in non-terrestrial network using machine learning. This work focuses on reducing unnecessary handover and improving connection stability in satellite-based networks. Um, So in non-terrestrial networks, mobile users are constantly moving between different satellites. This creates a significant challenge. Frequent and often unnecessary handover. This handover leads to what we call the ping pong effect, where a user bounces back and forth between satellites. It is known as ping pong, and it generates excessive signal overhead. So our project addresses this by using machine learning to predict optimal handover decisions, ultimately improving both network efficiency and user experience by reducing the handover failures. We reviewed like some literature papers. They have focused on rule-based approaches using fixed threshold are no longer efficient, and they uses mobility robustness optimization. So handover, however, most existing work focuses on terrestrial and hybrid network. Our work specifically targets non-terrestrial network with realistic satellite mobility and temporal behavior gap. So our problem statement is that in non-terrestrial networks, satellites are constantly moving, causing rapid signal variations. Traditional rule-based handover algorithm rely on fixed RSRP, which is received signal, received power, and signal to noise ratio threshold, which simply cannot adapt to this dynamic channel condition, which results in handover failure, ping-pong events, and unnecessary handovers that degrades both network performance and user experience. Our challenge was to develop an intelligent adaptive handover mechanism that can predict optimal handover timing under these varying non-terrestrial network conditions. Our objective is to first create a synthetic dataset generator that realistically simulates user mobility, satellite geometry, and signal conditions. Second was to train multiple models like gradient boosting, XGBoost, and CatBoost for handover prediction, and to evaluate these models using proper classification metrics like time-aware conditions and not just random splits. And finally, compare the ML model approach against baseline rule using system key performance indicators like ping pong failure rate and signal overhead. So this diagram shows the overall system workflow. So we start with dataset generator where we simulate user satellites and signal parameters. Our rule-based logic provides baseline handover decisions. Next, we perform feature engineering followed by model training. Then the trained model predicts handover decision and we compute KPIs before and after applying ML. Finally, we compare baseline versus ML model based performance. So this pipeline ensures fair and structural evaluation. So the reason for generating this synthetic data set was because real world non-terrestrial network data set is not publicly available, and satellite operators do not like release their mobility signal or handover logs. So instead of using incomplete or unrealistic data, we created this control simulation where we can model user movement, satellite motion, and signal parameters like RSRP, signal to noise ratio, and elevation angle. This simulation follows standard NTN assumptions and preserve temporal behavior. We have validated the dataset indirectly through model performance. Like our models achieved like around 0.86 ROC curve, and like it showed clear improvement in real KPIs like ping pong rate, handover failure rate, and signal overhead. So this is our dataset details. Our dataset consists of 200 users and it was run till 100 time steps. We used 15 satellite simulation and dataset was around 2 lakh rows, and we used this random shift to ensure reproducibility. Our dataset was a synthetic dataset. We used this RSRP signal, SINR signal, elevation angle, as I said earlier. And we used machine learning models like gradient boosting, and we also applied feature engineering to the data sets. So feature engineering like time normalization to capture temporal context and velocity factor to represent mobility, elevation quality, and a moving average of RSRP to smooth the short-term fluctuations. So we trained on three models of gradient boosting, which is a sequential model and it corrects sequentially and showed strong baseline performance. The second was XGBoost. It optimized for speed and generalization. And third one was CatBoost, which handles complex feature interaction and reduces overfitting. And all the models were tuned carefully. Um, and also, we have evaluated on some KPIs like total handover and handover rate per UV, ping pong rate, unnecessary handover rate, handover failure rate, mean time between error, and signal overhead. So this was the results. As you can see, earlier a total handover was like 3,000 and we have reduced it to 1,500. Same as handover UV rate and ping pong rate, which was 8.68%, and we reduced it to 2.45. So this is of gradient boosting model. And here is XGBoost. The orange graph represents the baseline, like how much the data set contained, and the green is our model's performance. So you can see there is a significant reduction in all the KPIs. And this is a CatBoost model. This has also performed very well. So this is ROC curve. So ROC is nothing but true positive rate against false positive rate across different models. In simple terms, it is like it shows how well the model can separate unnecessary handover rates from necessary handover rates. And the RSU value summarizes the curve into single number. So we have achieved an ROC curve of around 0.86 for all the three models. There is a significant change, like small, tiny change between each model. As you can see here, it is ROC accuracy of 0.8604 and 0.8595 and 0.12, 8612. So this is like overall improvements and key takeaways. Total handovers were reduced like around 1500 for all the three models, and handover UV per rate was reduced around 50%, and ping pong rate was reduced by more than 70%, and mean time between errors were nearly doubled, and signal overhead also significantly reduced. So overall, the cat boost and XG boost performed slightly better than like gradient boost. So gradient boost helped in reducing the total handovers, like as compared to XG boost and cat boost. So all the three models were like the overall performance was for cat boost and XG boost. So these three are supervised like models, supervised machine learning, and so our work is this, and we are open to your questions if you have any. And also these are papers we have reviewed for our project.
Okay, thank you. You can call next.
Okay, thank you, Narayan.
Okay, thank you, ma'am.
Can you please answer your presentation?
Yes, ma'am.
Okay, for next, I would like to call. Ilyas, are you present?
Yes, ma'am.
Yeah, you can start with the presentation.
Is my screen visible now?
Yes, it's visible.
Okay. Yes, ma'am, let me- yeah. So, good afternoon, everyone. I'm Ilyas Kunal, and today I'll be presenting our project title Adaptive Congestion Mitigation and TCP Networks via Reinforcement Aided Feedback Learning using NS3 So this project is all about, how we can improve the TCP handles congestion using machine learning. So, like, firstly, if I tell you, briefly explain the background. So, TCP is, responsible for reliable data transfer, but the major limitation of TCP is congestion control. So, most existing TCP congestion algorithms like, Cubic or Reno are all rule based. So, they follow fixed logics so which works fine in stable networks. But when we talk about the dynamic networks or environments like wireless IoT and 5G networks, so the main idea of our project is to try to make a TCP adaptive and intelligent instead of static. So the problem statement that we got was the core problem is that the traditional TCP condition control cannot react properly to changing network conditions because they have fixed rules like throughput reduces, delay also increases, and packet loss occurs. So the challenge is how can the TCP learn from the network and adjust itself automatically. So why we chose the reinforcement learning was because it is like suitable for like trial and error, and it improves decision using reward and penalty. That's how the system works, and it works well in dynamic environments. So instead of manually tuning the TCP parameters, we let an RL agent learn the best condition control behavior. So actually, what we try to do is, in simple terms, we connected a NS3 networking simulator with a reinforcement learning agent Python. So the agent continuously observes the network and takes the decision and learns from the feedback. This is how the self-learning TCP condition control works. So this is the like block diagram that I've explained. And how the system actually works is like when once the traffic is generated and it gets basically sent to the NS3 simulated network. So in NS3 we try to measure the values like throughput, delay, packet loss. So these values are then tried to send to the RL agent using NS3 gym. So based on this feedback, the agent decides like whether to increase or decrease or to maintain the condition window. So this loop keeps repeating, and the agent keeps learning. So like the main motivation to choose the projects were on like three main reasons. First of all, the traditional TCP algorithms are outdated in the market and for modern networks. And secondly, reinforcement learning has shown like strong results in controlling the problems. So third was the like future networks like 5G and IoT and cloud systems really need an intelligent and adaptive protocols. So the main objectives were clear. So like we tried to design an RL-based TCP congestion control agent integrated with NS3 and NS3 gem, compared it with traditional TCP variants, and tried to evaluate the performance using throughput, delay, and packet loss. So we did not use any external data set. It was all about uh, it like uh, it was like all generated internally using an NSR simulation. The network itself, tried to like produce the data, and the RL agent learns from the throughput values, delay, and packet loss. Like this is like the completely simulation-driven learning system, and not a dataset-driven one. We try to implement it in a like as you can see in a Ubuntu 22.04. So we use like NS 3.38 for networking simulation, and the NS3 gym, we try to convert it to connect it with like NS3 with Python, and Python libraries were installed like for the RL agent. So basically, we try to create a bottleneck topology to realistically like simulate the congestion. And the TCP like some of the like basic RL based TCPs like that we calculated were TCP Reno, Cubic, TCP Ya, and TCP Big. So these, gave us like performance differences. And then when we tried to, like implement on the two RL-based models, so one was the TCP RL, which was the packet-based decision making, and TCP RL again that was time-based. So decisions were, that were made from each particular fixed time interval. So, if I talk about the like results part. Basically, like TCP-RL achieved around 1.91 Mbps, throughout throughput with 195 millisecond delay, and the TCP-RL time-based achieved 1.987 Mbps throughput with much lower delay of 155 milliseconds. So packet loss also, tried to reduce significantly in the time-based model, and the tools like used that for that evaluation purpose was the flow monitor files, which give us an idea about the throughput, delay, and packet loss. So like yeah, if I try to conclude the like project after the flow monitor files, our project basically shows the RL agent that can improve with the TCP congestion control, and this proves that the AI-driven congestion control is a strong solution for future networks. So thank you. Thank you again.
Okay, thank you, Ilyas. Just next.
Okay.
Okay. Sir, you don't have any questions?
No questions. Sir.
Okay, I will proceed with next. For the next presentation, Megha, are you ready? Is your network issue solved? Megha? Okay.
Am I audible?
No, it's not
Hello.
audible. Yeah, you're audible now.
Can I do like next after this? I was not able to share the screen.
Okay, you will present at last then. I will announce.
5 minutes. Oh yeah, last one.
Okay. Is Preetham present?
Yeah, ma'am.
Okay, you can start with your presentation.
Yeah, okay.
And it's a humble request to keep your presentation up to 10 minutes only. Please don't exceed that.
Second, one more. Can I get some more time? I am facing some issues during sharing, ma'am. So can I get some more time?
Okay. How much time will require?
5 more minutes.
Or else can you explain your project in short, if it's possible, without the presentation?
Yeah, okay, ma'am.
Or else share your PPT to me. I will share that.
Yeah, okay. Where should I need to share it?
What?
How do I share it to you, ma'am?
Wait, I will send you the number or mail. Just a second.
Yeah.
Can you share it in the chat?
When you share it, it is visible. You can share it again.
Preetham, can you share the PPT in the chat?
Yeah, ma'am, I'm trying.
Okay.
Rajnandini, how many presentations remaining?
Sir, 2 presentations are remaining.
Uh, Including this Pritham's presentation?
Yes, yes.
Yeah, ma'am, I have shared.
Yeah, I will check them.
So yeah, good afternoon, sir, and all the respective uh, colleagues. So myself, Preetham, and I am from the Department of Artificial Intelligence and Machine Learning from St. Joseph College of Engineering at Chennai. So today I am pleased to present our research work titled Multi-Model AI-Driven Medical Consultation System. So where we are integrating remote photosomography, vision language model, and large language model for enhanced preliminary diagnosis. So it was co-authored by my colleague Praveen and guided by our Professor Kirbavesli ma'am. So basically, it is a in traditional clinical practices, medical diagnosis is a holistic and multimodal process. But physicians don't just rely solely on what a patient says, right? So instead, they simultaneously observe visual cues such as a facial appearance, measure physiological parameters like heart rate and blood pressure as well. But today's telemedicine platforms don't just do those things. They just basically depends only on the text based and uh, just by just connecting with the doctors. So what our research work is that we are planning, we just included AI like computer vision.
Preetham, is there an issue? Am I audible?
I think there is a issue. Rajnandini, you can call next Megha.
Oh, okay, sir. Megha, are you done? Can you
Yeah,
at least share your...
yeah, I'll share the screen. Right.
Okay, okay. You can. Am I audible? Hello? Am I audible?
Yes,
Yes,
yes.
you're audible, Megha.
Good afternoon, everyone. My paper title is Optimized Radio Resource Allocation for 5G NB-IoT Networks using a Learning Framework. So this paper basically focuses on in 5G networks, a major challenge arises when high bandwidth 5G applications such as video calls, 5G networks, gaming, these all coexist with NB-IoT devices. Like NB-IoT devices are low battery devices like sensors, smart meters, and all. Sensors, these all come in NB-IoT devices within the same spectrum. So when the coexistence takes place, there's a wastage of bandwidth, and spectrum management is not like good. Traditional radio resource management techniques are static and relative. They cannot adapt to rapid traffic variations. They cannot adapt to changing traffics, which leads to congestion and higher latency and unfair quality of service. So we are basically in this paper we are working on the latency and quality of services of both NB-IoT and 5G devices. Um, so in the literature survey, we observe that most existing works use rule-based or classical optimization techniques which do not scale well in dynamic environments. They work well in static environments but do not work in dynamic environments. Some works use reinforcement learning, but they react only to current network conditions and do not consider future traffic patterns. So our problem statement was basically to develop an adaptive and intelligent radio resource management framework for coexistence using LSTM based traffic prediction. The problem is to design an adaptive and intelligent resource management framework for 5G NB-IoT devices that ensures quality of service, fairness, and low latency under dynamic traffic conditions. So the four objectives of our project are to design an adaptive framework, use LSTM for traffic and SINR prediction, used DRL, which is deep reinforcement learning for optimal resource allocation, improve quality of service of both 5G and NB-IoT devices, and to evaluate the coexistence of both. So the functional block diagram. First comes input block. So this first we generate a synthetic data set considering of 5G NR users like video call, emergency. These all services we have generated a data set of 100 users. The data set is pre-processed and fed into the LSTM forecast module, which predicts next step traffic load and SINR. These predictions are then combined with the current network parameters. The RL agent takes actions in a custom MATLAB environment, which simulates real-time 5G and NB-IoT coexistence logic based on the action and this. In our methodology, we first generate a synthetic data set considering of mixed 5G users, which I said earlier. The data set is pre-processed. These predicted values, along with the current network parameters such as latency and throughput, from the state input to the soft actor critic reinforcement learning agent. The SSE agent, which is soft actor critic agent, dynamically allocates these resources, radio resources in custom MATLAB using the trial and error method. A reward function evaluates quality of service. This was the methodology. We generated a data set with 1,000 users where NB-IoT operates in 180 kilohertz. For NB-IoT, we have set like 180 kilohertz as the bandwidth. And for 5G, we had taken like 0 to 100 megahertz. The LSTM model successfully learns periodic traffic patterns. This is the predicted data traffic and predicted signal. These are the quality of service. For emergency, we have given like a highest priority, and quality of service of video calls and video streams are also high, whereas the smart sensors and these, even those are prioritized, but quality of service also has been improved compared to the data literature survey papers. These was the priority based resource allocation. Highest priority is given to emergency. We have allocated by giving priority. Highest priority is given to emergency, and then these video calls, and based on that, smart sensors and BIoT are given least priority. These were the quality of service and SAC soft critic results. So
So in this performance of quality of service of SAC, we have actually compared 5G versus NR mobility. Like for throughput, we have compared 5G and NR mobility. For latency also, we have compared 5G and NR mobility. Like this, we have done till drop rate, throughput, latency, and quality of service of all.
these were the logging and performance evaluation of these, like for emergency call, how much it is allocated and how many megahertz. For throughput, what it is all allocated. These were the log functions. Yeah, these were the results achieved. Like for quality of service, before optimization, it was like moderate. After we used our algorithm SAC plus LSTM, significantly higher balanced and improved results. We got all these for all improved results for latency, reliability, and priority enforcement. So yeah, this was it. In this work, an optimized radio resource management solution for in conclusion, we proposed an AI-based radio resource management framework combining LSTM and SAC soft actor critic. The LSTM model enabled future-aware decision, like by predicting traffic and next steps, while SAC ensures stable and optimal resource allocation. Hence, this approach is well suited for dynamic and heterogeneous 5G and BIoT environments. Thank you. If you have any questions, like call.
Have you compared your work with existing works?
Yes, we have compared it.
So how many techniques you use for comparison?
We did not compare it, but the previous works through literature survey, they had used like a round robins reinforcement learning frameworks, and these all they have used. So compared to their work, our quality of service and these are much higher.
Okay, fine. Thank you.
Thank you.
Okay, thank you, Nikita. I wants to confirm that is Ogochukwu is present in the meet now.
What?
I'm not asking to you, sorry. It's not for you. In the meet, is Ogochukwu is present? Okay, he's not there. So this was the last research paper. We can go with our closing.
Ma'am, you are ready to present, right? Preetham.
You want to continue, Preetham?
Yeah, ma'am. Will that be okay?
Okay, you can share your screen.
So yeah, sorry for the inconvenience before. So like I said before,
Sorry for the interruption, Preetham, but
yeah,
could you please complete the presentation within the span of 8 minutes?
yeah, sure, ma'am, okay. So guys, so like I said before, our research work is based on the uh, like combining multimodal features like RPPG, VLM, and large language models. As we know, even in our smartwatches, we use green color signals that we use it to measure our heart rate and blood pressure, right? So the same technology is what we are using with the help of a camera to collect our health vitals like heart rate. So along with that, we are using vision language model to get the cues, facial cues, like how the person's eyes are, whether it is red or something yellowish, from which we can jaundice or something like diseases can also be identified. So one more next thing we use is that large language model. So by combining all these three things, we are basically creating a triad, like how doctors consult a patient. First, there is a lack of synchronized multimodal processing in the usual things. So most system operate sequentially or independently, whereas our system, we are also including spatial localization of symptoms. Like uh, as a telemedicine platforms, they might not properly indicate where the real pain or problem is. So we use visual symptom mapping technology to map the exact place where the people is getting a pain or uncomfortness. So we taking it as also another future. So by combining all these things, we are creating a multimodal future to diagnose a patient. So basically, AI-driven diagnostic systems lack robust and clinical safety mechanisms. So because of which they may not give a proper answer or they might hallucinate. So to avoid those things, we are proposing a human in the loop kind of a thing. So when high risk cases is encountered, they goes to a human verification before they proceed to a patient for the results. So basically, remote photosmography is a technology which helps in contactless extraction of physiological signals such as heart rate and blood pressure. And vision language model, we use it to extract clinical relevant visual symptoms. And one more large language model, we use it to create a context-aware clinical reasoning or fused multimodal representations. So basically, this is our research work, ma'am. Thank you. Yeah, thank you, ma'am.
Sir, do you have any question?
No question.
Okay.
So I think all presentations are done, right?
Yes.
Would you like to say something, Rajnandini?
Yeah, sir. Then you can. So I sincerely thank our authors for their excellent presentation and contribution in this session and all our participants for being a part of this international conference. I hope this session were informative enough. We on behalf of the whole team thank you for the support during this 10th version and all the previous 9 version of the conference. We will be happy to have you in 11th version in 2027. All the presenters will be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of SMARTCOM. I also thank our session chair, Dr. Lumesh Kautikahire, for chairing the session. A token of appreciation to the chair on behalf of Team SmartCom 2026 and Global Knowledge Research Foundation and partners. Thank you, sir, for your valuable presence. Would you like to address the participant?
Yes. Just a minute.
Yes, sir, you can proceed.
Okay, with the closing remark for this session of SmartCon 2026, I would like to sincerely thanks to all presenters who actually did the nice presentations and within time also. I also like to thanks for audience to listen silently. Okay, and finally, I would like to thanks all the organizing team. Okay, to give me the chance as a session chair for this session. Okay, thank you.
Okay, thank you, sir. Now I request everyone to switch on the camera for a quick snapshot. Okay, thank you everyone. Thank you, sir.
Thank you.